The equation of a curve is given by x cubed plus y cubed plus 2xy plus 8 is equal to 0. So express dy dx in terms of x and y. So this is a question that requires knowledge of two important aspects of differentiation. The first one being being the implicit part of differentiation. Then so for the implicit, we just say the derivative of a term in y, you just differentiate power times coefficient, you subtract 1 from the power, then you put a dy dx. So that's the first part of differentiation that shall be tested here. And the other concept that is being tested as well is the differentiation of products, of which when you differentiate products, it's v times derivative of u plus u times derivative of v. That's what is being tested in this question. So we start. We differentiate our x cubed, that will give us 3x squared. We differentiate our y cubed, that will be 3y squared. And of course, the dy dx is important. Plus, now we differentiate 2xy. 2xy is a product that is made up of 2x and a y. So we'll go u dv v du. So that's going to be u, which is my 2x, times derivative of y, that's 1 dy dx, plus y times the derivative of 2x, which is a 2, like that. Then derivative of 8 is a 0, and also derivative of the 0 is also a 0. Now from this stage, what are we doing? We are going to make dy dx the subject of the formula, which means these terms that have dy dx shall remain on this side, and at the same time I will factor out dy dx from those terms, and I will remain with 3y squared plus 2x is equal to, I'll take the other terms to the other side. I will have negative 2y, negative 3x squared on the other side. So from there, what happens? I'll divide both sides by the bracket, and I'll end up with negative 2y, negative 3x squared all over 3y squared plus 2x. So that's how we get the derivative of this function. Now the tangent to the curve at the point where x is 0 and the tangent to at the point where y is equal to 0, they intersect at the acute angle alpha. Find the exact value of tan alpha. All right, so our first task right here is to get the complete coordinates where x is 0, complete coordinate where y is 0. So we go back and get our equation, x cubed plus y cubed plus 2xy plus 8. And this is equal to 0. All right, so from here, what's going to happen? We substitute when x is equal to 0. We solve, we get y is negative 2. So we now have our first set of coordinates, x is 0, y is negative 2. Then we also want a coordinate when y is 0. We want to know what x is. When y is 0, what is x? So you substitute y is 0, you also get x is -2. So there we are. We now have a pair of coordinates. Then the next thing is we need to get the respective gradient for each of these. So gradient is going to come from the dy dx. So our dy dx was -2y minus 3x squared over 3y squared plus 2x. So -2y minus 3x squared all over 3y squared plus 2x. This is our dy dx. This is our gradient function that we use to find the angles, because the angles come from the tan function of angles, of gradient rather. So let us substitute our first set of coordinates. X is 0, y is -2. We substitute here into dy dx. That's going to give us a gradient of how much? X is gone, 0, 0. Then we substitute y is -2. That will give us a 1/3. Next up, we also deal with the second set of coordinates. What are we going to do with it? We are going to substitute that pair of coordinates right there. Right, so if we substitute there, in place of y we put zeros, in place of x we put -2, then we would end up with a gradient of 3. Now we need the value of tan alpha, the angle. Our tangent of alpha, the angle, shall be equivalent to the tan of the second angle there, which you can call A, minus the tangent of the second one, because this is a point of intersection where those angles are going to subtract each other. Right, so according to your trig identities now, tan of A minus B, that's tan A minus tan B all over 1 plus tan A tan B. That's the identity for this. So let us substitute. Tan of alpha becomes tan of A, which is a 3, minus tan of B. Right, I'll take that again. Tan of A, which is a 3, minus tan of B, which is a 1/3, plus a product of the two tan functions. All right, so our numerator will give us 8/3. Our denominator will give us a 2. And when we divide, our tan alpha would give us 4/3.